will only have 4 lessons for the class. This unit will only have 4 lessons, but you're not being deceived by the low amount of lessons. This is the most intense math unit because you'll be using algebra to solve most questions, a mix of algebra and conversions. And so you'll need to study, you'll need to practice. Remember, there's tutoring on Mondays. I always do tutoring on Mondays. I did go ahead and put up the date of the Unit 7 exam. It will be the 29th and 30th, depending on if you're A day or B day. Those will be the dates of the exam. The reason why it's only 4 lessons, but yet it's taking a month to go through is because I am giving time to do labs in between several of the lessons. And so what's coming right up the pike after today's lesson, you will have a homework for today's lesson because you need to practice what you're going to learn today. And then next class, you are going to have a lab. So that's a reminder for you that you must have closed-toe shoes on Monday. I'll send a message Sunday, but you must have closed-toe shoes on Monday to participate in the lab. So make sure that you put that into your schedule so that you're ready and prepared for that. All right, so one more thing. There are no quizzes this quarter, no quizzes. The only exam grades are the exam grades. So you have to be completely prepared for the date of the exam, which means the exam's worth a little bit more. You've got to make sure that you're using the lower quizzes that we do and you're doing the practice effectively so that you can be well prepared for the test, which will be, like I said, for this test is at the end of the month. The good news, this is the last unit of mathematics. So after this unit, the last unit, we're going to actually go back to like drawing Lewis structures when we do our last unit of study. So I try to give something that's considerably simpler at the end of the year, but this is pretty much the heftiest unit, even though there's only 4 lessons because there's a lot of math in here. All right, so we're going to go ahead and get started today. Today, we are going to be going over the pH scale, which I introduced to you a couple of months ago. We did a mini lesson on acids a while ago. And we're going to be learning how to perform pH calculation. So how to determine the pH of any solution. The lab you're going to do on Monday, you're going to be testing the pH of many different solutions, like apple juice, energy drink, soda, and see what those pHs are. That's what you're going to be doing on Monday. And so today we're going to learn how to do the calculations, and you are going to, in your lab on Monday, have to do calculations as well. All right, so let's get started. Formulas to memorize. Breathe in, breathe out. There's a lot of formulas in this unit. I'm going to try to make it a little bit simpler for you. The 2 you have to memorize right now are the ones from lesson 1. You must memorize these 2, meaning the concentration formula, that is molarity as moles over liters, you've got to know that by heart. And the one for dilution of solutions, you've got to know that by heart. In the AS chemistry class, you are expected to know those formulas by heart. So I always go with what would Cambridge do? You have to memorize those 2. pH actually at the Cambridge college level isn't covered until A-level chemistry, which is like the 3rd year class. Therefore, I'm not going to make you memorize this whole large set of formulas in pre-ACE. I'm going to give these to you on the given on exam. So you will get a small formula sheet on the exam, and it's going to have your pH formulas there. Yes. I did? All right, thank you. I will get back. So the reason I'm bringing this up is because you need to pay attention to what resources you're going to have and what resources you're going to need to pull off the top of your head. Let's see if the internet comes back. be getting back in. A little slow today. Can you say that? All right, so just to remind you what I had written before, these two formulas you must memorize, right? And the formulas here I'm actually going to give you, given, but you're still gonna have to know how to use them. There's going to be in the future lessons a couple more formulas, and I'll let you know whether you have to memorize those or if they'll be given. But this is just to keep it clear what you should be studying as you're going along. Now, of course, as you're doing the future Bellwork quizzes, like next class, you'll be allowed to have this formula sheet on you so that you can reference to what you're going to be using to solve each question. So let's go ahead and get started. We're going to start here, and you'll notice that the slide is mainly blank. I'm going to add information to it. The title says the self-ionization of water. And yes, I spelled it the Cambridge way. Ionization spelled Cambridge has an S in the middle. They change all Z's to S's in the middle of words. So in American curriculum, you would see this is a Z, but in the Cambridge International curriculum, it's an S. That's British. So in pure water, at 25 degrees Celsius, that's just standard temperature, the concentration of hydrogen ions, that's H+, is 1 times 10 to the negative 7. What does this mean? First of all, what is the formula for water? It's not a trick question. H2O. So write that out. Do you remember hearing about ionization at some point in this class? Yeah. What did that mean? Breaks apart. So how would water, if it broke apart, how would it break apart? How would it ionize? Nope, it would not break apart into H2. It would break apart into H+ and OH-. Those are the two components of water. I'll mention where H3O+ comes into play in the Bronsted-Lowry theory lesson. That's not until next week. But this is the auto-ionization, we call it, of water. Water breaks apart a very, very, very small amount. That's why you see the double arrows here. Double arrows means reversible reaction. You won't really see, I've told you before, you won't really see much of that in this class. It's more for the AICE study. But what it means is that you're only going to have a little bit of water that breaks apart, and most water stays H2O. Like, what do I mean by a little bit? They've defined a little bit here. A little bit is 1 times 10 to the negative 7. So you should write under here, 1 times 10 to the negative 7 molarity is actually the amount of H+ that breaks apart. And it tells you, if you've got an aqueous solution where H+ and OH- are equal, we call this a neutral solution. Water is a neutral solution because when water breaks apart, you get, for every one water, 1 H+ and 1 OH- in the balanced equation. So if there's 1 times 10 to the negative 7 molarity of H+, then what's the molarity of OH- in the same solution? What do you think? It would be the same exact number, so you should write that down. If the amounts are equal, this means you have a neutral solution, and you should have context to know that water is neutral. Water is neutral. It's your most famous neutral solution because the amounts of H+ and OH- are the same. Now, how small of a number is 1 times 10 to the negative 7, just to give you some context? Because one of the things in chemistry is you have to understand. These numbers have meaning. How small is this number? 1 times 10 to the negative 7. What is this? This is scientific notation, right? What would this be in standard form? Like that, right? Yeah. 0.0000001 molarity. And what does that communicate? That's the amount of moles that's dissolved in 1 liter of solution, right? Is that a big amount or a small amount of moles? What do you think? 0.0000001.
That's a small amount. That's small.
Extremely small. And so now we're defining what exactly a small amount is. Water breaks apart a tiny bit, specifically that amount. We call this the self-ionization of water, and it automatically happens. That's why if you put a pH meter in water, it's going to register a pH because there's an amount of H plus ions in pure water. A very small amount, not enough to conduct electricity, but a small amount. All right, pH scale. I believe I have went over this somewhat with you earlier this year. There are a couple of things you need to keep in mind about the pH scale as we're going through this lesson. First, hopefully it's been established that pH of 7 is a neutral pH. And what this actually means is your concentration of H plus equals your concentration of OH minus. Your amount of acid and your amount of base is the same. And before I move forward, this is important for future reference. Whenever you see brackets, and this is going to happen throughout this whole entire lesson, whenever you see brackets, and this means that we are talking about concentration, and specifically the unit of concentration we're talking about is molarity. So when you read this, you're supposed to read this as the concentration of H plus is equal to the concentration of OH minus. Brackets means concentration, so brackets actually means molarity. You always plug molarity into brackets. So just so you're aware, that's a contextual thing to know. So then what about less than 7? If the pH is less than 7, what does that tell me about the relationship between the amount of acid I have in a solution and the amount of base? So there's more H plus ions. There's an imbalance in pH, and this means that there's more H plus ions than OH minus. And you could look at this mathematically and say the concentration of H plus is greater than the concentration of OH minus. You've got more acid than base in your solution. That's why we classify it as acidic. And then for above 7, what does it mean when the pH is above 7?
OH.
Or OH. We call this the alkaline solution. Basic and alkaline are synonyms for each other. More OH minus then H plus, or your H plus concentration is less than your OH minus concentration if you're able to look at greater and less than signs correctly. Now, there's one other thing. I don't remember if I mentioned this. I mentioned it in some periods, but not the other when I did the initial lesson on acids and bases. So I'm going to make sure that I've covered with everyone now. Every movement of 1 on the pH scale is a movement of how many times more acidic? You remember? If I move from 7 to 6, it's 10 times. And we're going to look at the math behind that today. But every movement of 1 on the pH scale is actually a movement of 10 times more acidic or 10 times more basic. So I'm going to do 10x for 10 times. Meaning that if you take a measurement, and you are going to be taking measurements of solutions on Monday, and you see the pH is 3, what does that tell you about the amount of acid in that solution compared to the amount of H plus in water? If every movement of 1 is a 10 times more, it would actually be 10 times, it's compounding. So it's 10 times, 10 times, 10 times, 10 times more acidic. So what's 10 times 10 times 10 times 10? 10 to the 1 to 4, right? So this would be 10 to the 4th more times acidic, which is 10,000, just to give you a number. But that is, because a lot of times it's better if we just see it in the numbers, 10,000 times more acidic. And so every movement of 1 on the pH scale is a movement of 10 times more acidic. And if I went the opposite direction, above 7 to 14, every movement of 10 would be 10 times more basic. Does that make sense?
Yeah.
All right, so that's looking at it theoretically. But we're actually going to do the math. We're going to do the formulas behind this that proves this information today. Ready? Breathe in, breathe out. I talked with Ms. Sauerowitz because Create Math 3 is the class you are supposed to be taking. If you do take this class with geometry, it's not the end of the world, you survive. But technically, Create Math 3 is the correct corresponding class because that's equivalent to Algebra 2. And she told me, she promised me she would cover logarithms with you all because it's important to cover. I asked her 2 days ago and she said she's covering it next week. And I was like, okay. So you're gonna hear logarithms from me first, and then you'll hear it from Miss S. If you are in Create Math 3, you'll hear it next week, so the two will actually quite correlate with each other. It is not a fatal flaw. If you are in geometry, you will be able to do what you need to do. Because at the end of the day, all you're going to have to do for this class is plug a button in a calculator to figure out what a logarithm is. Miss S will teach you all the logarithm rules. If you are in Create Math 3, she'll be teaching them to you next week. You'll also learn about logs when you take college algebra in university. So if you've already taken that dual enrollment, then you would have seen what a logarithm is. But here we go. Here's the math. This is the most advanced math of the year in this course. So here it is. To calculate the pH of a solution, there's a formula for this. So this is formula number 1. I'm going to go over each of the formulas you need to know. And I'm going to go a little bit into the math, but not too much. I'm going to save most of that discussion for Miss S. For now, this is a formula you need to know. So formula number 1, this is if you are given the H plus concentration and you are asked for pH. The pH is equal to the negative log of the concentration of H plus. You're like, what in the world is log? So beforehand, in your calculator, you would put negative. This is a button on your calculator. Which is why you must have a scientific calculator. And then you would put parentheses, whatever your concentration is, close parentheses. How you're going to solve questions in your calculator. What is a logarithm? Well, have you ever seen a function like this before in math? Y equals 10 to the x. What type of function is that? Beautiful. So that's an exponential function. What a logarithm is, just to give you a basic idea, is the inverse of the exponential function. You know how there's inverse functions that exist? So like the log. Yes, that's exactly right. Are you in Create Math 3?
Yeah, I am.
But the epistle mentioned it. Okay. The inverse of the exponential function is the logarithm. So it turns out that that's absolutely a correct idea. And the logarithms can have different bases, but the only base we're going to work with in this class is base 10. And that's so that we can do those nice movements on the pH scale. So this is invisible here, but your calculator automatically assumes logarithms are base 10. And so you can write that in if you want, but like I said, your calculator's already going to have it with the correct base. All right, so that's what a logarithm is. I'll show this to you graphically in a little while so you can see that as well. But for the most part, to calculate pH, you're just going to have to know how to use this in your calculator. So here we go. Calculate the pH of the following solutions. So you've been given a concentration of acid in each of these, and you're being asked to find the pH. So it's how to use the formula. The formula is pH equals negative. Make sure you use the negative key on your calculator, not the subtraction key, or you will get an error. Log, and then in here is your concentration of H plus. So let's see if you can do the first one. Try it in your calculator. pH equals negative log, and then it would be of 0.0001. Try this in your calculator, see if you can find the log key. Different calculators have it in different places, so I can't tell you exactly where it's at. You gotta look for that button on your calculator. You press the negative key, then the log key, then you put the 0.0001 number, make sure you put parentheses around it like it is in the formula. And then if you get it right, you'll get the number 4. Check to see if you get it. If it gives you an error, syntax error, have me check, because it means something was entered wrong. This is the negative key. Did you use that or did you put parentheses? You have to use the negative key. All right, so this describes to me if I've got a 0.0001 molarity concentration of H plus, then my pH is 4. Let's think about that. Does this describe an acidic or a basic solution? It's acidic, right? It's about 1,000 times more acidic than water. Right? 1,000 times more acidic than water. Yes. Yes. Me writing the parentheses is saying that. Don't use the subtraction sign. And don't use parentheses here. This is a key.
No,
This is a key.
yeah, I got it.
And then
No,
parentheses
just
here.
because you put.
Right, so that you know which key to press. All right, let's try the next one. pH equals negative log 15.2. So the same button. This is the negative key, and then this is the log key in your calculator. And then you have to open and close the parentheses and put the number inside. If you do it right, you get negative 1.18, which we definitely have to talk about. Negative 1.8. So make sure you get that in your calculator, that you know how to enter it in your calculator. This is the time to figure it out. If you have calculator issues, especially on that third one when you have that exponent, you may have some calculator issues. You gotta let me know. Okay, let's talk about this. Whoa. Go back to the pH scale. Is that exist? Can a negative pH exist? Have you ever heard of a negative pH? It's the distance from neutral, yes. So the pH scale as it's been described to you in elementary school and middle school is, I believe, been from 1 to 14 actually. This one says from 0 to 14. But would you believe that this is not the end? These arrows go both ways. So the pH scale can extend past 0 and it can extend past 14. So what does a pH of negative 1 mean? 10 times 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 10. I think that's 100 million off the top of my head times more acidic than water. So what is that? Extremely strong. So this is a very acidic, extremely strong acid. And I believe I had mentioned in the first lesson that I could look at a concentration and tell you if that's extremely dangerous or not. So when Miss Lee looks at a bottle that says 15.2 molarity hydrochloric acid, I say, gloves, goggles, probably a respiratory mask because it's that strong of an acid. So strong that the fumes come up and you could breathe it in, it'll cause you respiratory distress because you'd be breathing in some acid, actually. I got a story for you before we move on. And the reason why I'm telling you the story is these numbers have meaning. And that's the thing about science. These numbers aren't just numbers. These numbers carry meaning to them. If I see 15.2 molarity concentration acid, I'm scared. And I'll tell you exactly why. When I was 19 years old, I was taking organic chemistry. And we had an organic chemistry lab section. And we would work sometimes with strong acids. The instructor told us to wear our gloves, wear our goggles, and somebody didn't put on their gloves. Like sometimes some of you forget, and I run around and tell you to put on your gloves.
Did they get a chemical?
They needed to use sulfuric acid, and it was about, I'd say, a 13 molarity concentration. And it was in a fume hood, and they didn't have their gloves on, and they had unscrewed the cap, so they just touched like a drop of sulfuric acid. They started screaming bloody murder within seconds. I saw their hand and it was bubbling. Like the skin was bubbling. They went to the hospital. They were immediately, escorted to the hospital. They survived. Saw them a couple weeks later. But you don't forget those things. So when I tell you, when I was 19, taking organic chemistry, you don't forget these things. And it was an early morning class, by the way, when you're real tired and you forget like things.
Wow, you have core memory.
It's a core memory.
Forget.
Traumatizing. But that's why as a teacher, I don't forget to remind you exactly what your safety things, because I've seen the worst of what can happen. So did you see how? No, they had it all wrapped up a couple of weeks later, so I didn't see like that aftermath. I only saw like that day.
But you can imagine all the bubbles.
It probably made I don't know if they needed skin grafts or not, because sometimes with people burns you need skin grafts, especially if it gets on your face or something.
Just one drop.
Well, for them it was just one drop. They touched just the cap of the container had like a spare drop on it, and that happened. They had to go to the hospital, and let me tell you that professor was angry because they didn't listen to instructions, and it was like, this is the reason why. But anyways, the reason why I'm telling you this story is because you look at a bottle of a solution and you see a number on that bottle, you see a number on that beaker with a label, that number carries meaning. If I see 15.2 molarity of acid, I'm scared. If I see 0.0001 molarity of acid, I'm not scared, because a pH of 4 is something like the pH of a juice. Like some juices have a pH of 4. And so the numerical value of your pH actually gives you a lot of information about the strength or weakness of the acid or the base. So just bringing that up as we're going along. And no, I'm not going to give you anything that's scary next class. I won't give you anything that's depends on what Cambridge does. The worst they work with, I believe, 1 year they did have a 13 molarity HCl that they had to work with, and I was terrified for them. Depends on what Cambridge requires, honestly. Regularly you work with 2 molarity. That's the typical amount you work with, which is enough to give you like a burn that'll sting. It'll sting, but not enough to like burn your skin off. So it's that's usually the amount you work with in the A class. Anyways, let's go on to the next one. 3 times 10 to the negative 9, H plus. So for this one, you gotta make sure you remember how to use your calculator with exponents. So I'm gonna remind you, you do 3.0 times 10 raised to the negative 9. Make sure you use the negative key both here and here to get the right answer. And let's see what we get. So try this one again yourself. Verify you get the same answer as I do. Xavier, what's up? Not 4.52.
I got 8.5.
8.5 sounds right. Let's take a look. Let's see. You guys know. You don't need to. I heard 0.5. 8.5 is correct. Check to make sure you get the same answers. Once again, half of what we're doing today is making sure when you use the formula, you know how to enter it incorrectly. You don't have to know all the mathematical logarithm rules, which is why I said it's okay if you're in geometry, you don't need to know but know how. However, if you are in free AICE Math 3, you'll be learning more about logarithms next week from Miss S. Alright, so make sure you get 8.5. If you don't get 8.5, you need to let me know now. If you're too shy to ask me now, you can ask during tutoring, but there's no excuse to get it wrong on the test because you didn't try doing it in your calculator. Did you get it?
I don't think I need to get another calculator.
Oh yeah, that's the yucky one. I don't like that. Try one of these. This is the one I specifically, I don't know if I told your class, but this is the one that I suggest not using. The TI-30XA. Unless you're good at it, but it reads everything backwards. So I don't know.
Oh, that's why I got it backwards on the first one. How if I tried the other way? Or the number first and then the long.
Yeah, everything enters backwards. Yeah, there's high security there, and you have to sign a bunch of contracts, basically that the school is not liable for you injuring yourself. All right, guess what? It's your turn. Time for your first stamp. In the next 3 to 4 minutes, please try these 2 questions. And if you have them both correct, you'll get stamped. Remember, the stamp is going towards extra game points at the end of the year. I am doing a final binder check. I expect all your printed notes with writing solved. And then for each stamp that you've earned, every 2 is going to be an extra game point. So this one is your turn. You've got 3 to 4 minutes. When you're ready, have me check. I just have to resolve them out real quick to make sure that I can check them real quick. Don't forget to consider significant figures in your final answers. All right, so I'm going to come around now and start checking. Go ahead, grab the packet. All right, remember, once you have both the answers, let me know and I'll check them for you. All right, I'm gonna be checking for about 1 more minute and then we're gonna continue. more seconds and then I'm moving forward. All right, so we are going to move forward. If you need me to go back and check your work for the first stamp, when it's time for the second stamp, just let me know, and I'll do both. We're going to go ahead and continue, though, because that's not the only formula. The only reason I spend more time on that is just so you know what a log is, kind of, so that you enter it into the calculator correctly so you can do proper calculations. So moving on. Take a look. This is a relationship between H plus, OH minus, and pH. I want you to take a look at this carefully. In an initial solution, we know that our amount of H plus is equal to our amount of OH minus. Both of them are 10 to the negative 7. What's the pH of a neutral solution? 7. So when the concentrations are 10 to the negative 7, the pH is 7. Okay. 1 times 10 to the negative 8. When my acid concentration is 1 times 10 to the negative 8, my base concentration is 10 times 10 to the negative 6. And what's my pH?
8.
Which is directly related to what? Which concentration is the pH directly related to? The acid or the base concentration? When my acid concentration is 10 to the negative 12, my base concentration is 10 to the negative 2, and my pH is 12. What is my pH directly related to? The acid concentration. And if you know how logarithms work, I am going to bring it up for your class. If it's negative log 10, 10 to the negative 12, it actually turns out that log 10 just disappears because it's the inverse of the exponential function. So this all disappears and you get negative 1 times negative 12, which is just 12. So you can, if you have a whole number, like 1 times 10 to the negative 7, 1 times 10 to the negative 8, you can automatically say that whatever that exponent is for your acid is equal to the pH. That's the first thing I wanted to bring up. The second thing I wanted to bring up, notice something about the concentration of acid and base. When one is 1, the other one is 13. When one is 8, the other one is 6. Or negative 8, negative 6. You can notice a pattern between the concentration of acid and the concentration of base. The exponents always add to become the same number. Do you see what that number is? The number 14 have any relevance for us in pH? That's what the pH scale is derived off of, right? So it's because the concentration of acid and base will always multiply to become 10 to the negative 14, and that's where the pH scale is based off of, which has a more deep context that you all will not learn until, if you study future chemistry, you'll learn more about why it's 10 to the negative 14. But without explaining equilibrium, it won't make sense. So, just interesting patterns for now. This is graph of y equals log 10 or negative log 10 to the x. Look like math, doesn't it? Y is pH. So pH is on the y-axis. And x is your H plus concentration, which is on the x-axis. So you could, like you do in mathematics, and I bet some of you will next week, you'll be graphing logarithmic functions, and you'll be plugging in x values and finding out what the y values are, and you'll be making a graph out of that. I just wanted to bring up that these two ideas, the mathematics of the graphing and what you see in chemistry, are actually directly related to each other. What does this mean? Look at your hydrogen ion concentration. When the pH goes up dramatically, it's when your concentration is really, really, really what? Small. So when it's really small, your pH shoots up dramatically. When your hydrogen ion concentration gets large, you'll notice that it taps out at below 2. All of your strong acids have pHs pretty much below 2, and that's why you were taught that in the past by earlier science teachers. They say 0 to 2 is a strong acid because of this. This is the mathematical relationship between the strength of your acid and the pH. Will I be asking you to graph in the previous class? No, this is just to give you some context of how this relates directly into mathematics. All right, so what are we going to be doing? What are you going to be asked to do in this class? The first thing you were asked to do was, if you were given the H plus concentration, I could ask you for the pH. Now, if I give you the pH, so this is formula 2, that you're going to need to know how to use for the lab and for the exam. Formula 2 is, if given pH and asked for H plus, you would use this formula. Why? Because H plus is by itself on this side of the equation. Whenever something's by itself, that's what you're going to be solving for. And so, see if you can enter each of these in your calculator to get the correct answer. For the first one, pH is 3.53. So how would we find the H plus concentration from this pH? We would do 10 to the negative 3.53. Now I have a question for you, formatting wise. Can we leave an answer like that? Is that standard form? Does anybody understand what 10 to the negative 3.53 is? People don't communicate like that. So if you have a decimal exponent, it must be put in the calculator to figure out what the actual standard form is, to find standard form. So go ahead and enter 10 to the negative 3.53 in your calculator and see if you get the right answer here. So you have to fix it, basically. And it's easy to fix if you've got a calculator. You do not have to do any of this in your head, nor would you ever want to try. Depending on your calculator, you will either get the answer in scientific notation or not. So I'm going to write out both possible answers. You could have a calculator that told you 2.95 times 10 to the negative 4. That's correct. Or you could have a calculator that gives you the answer in standard form, not scientific, 295. This is also correct. Question. Is one form better than the other? 2.95 times 10 to the negative 4. Most people who will major STEM will tell you that scientific notation would be the proper way to answer your question. Scientific notation is best used when you have numbers that are greater than 1,000 or lower than like 0.001. That's when we opt for scientific notation. Now my next question, will Cambridge give you a wrong answer if you write this? They don't. They'll give you the answer correct if you give the correct answer in either form. So I'm just being upfront about that. Lucky for you, when your exponents get too big or too small, your scientific calculator should automatically change the scientific notation. But you can also, I taught you earlier this year how to change the scientific notation in your calculator. And if you forgot, or if you weren't here, or whatever reason, you need me to reteach you, I can't do that. Wait a minute. All right, let's try the second one. pH, 6.67. What is the concentration here? 10 to the negative 6.67, which is 2.1. I think it rounds to 4. Because 2.137, 9. So it would be 2.14 times 10 to the negative. Or the corresponding with all the zeros written, but I don't write all the zeros. That's the purpose of scientific notation, is not to write. Because remember, if you miss 1 0, it's wrong. And we've had that come up already, where you are off by 1 0 and your answer is wrong. All right, 10 to the negative 9.35. I get 4.47. 10 to the negative 10. And everybody should get an answer in your calculator that looks like this.
I got 4.46.
It should round up because the number after 6 is a 6. It should round up. Remember, you do need to follow standard rounding rules when cutting off for significant figures. So, second formula is basically the backwards, the inverse of the first formula. So that's why I said if you understand the math, it's actually less formulas to memorize. But I'm not making you memorize any of these pH formulas, so you just have to know which to use each one. We're going to continue. Just continue? Okay. So we're going to go on to our next formula. I forgot before I printed this out to write the formula on the slide, so you're going to write it out. The formula to convert between OH minus and OH. You could look at the first page and see if you could identify which formula is appropriate. The slide that says formulas to memorize, new today, I have all the formulas written for you there. Which formula do you think is going to be the appropriate one before I go ahead and write it on the board? Because I think, you're savvy. You can figure it out. To convert between OH minus and H plus, which formula would make the most sense? It's going to be the one that's number 6. So the formula that you would need to use here to convert between these two is H plus multiplied by OH minus equals 10 to the negative 14, which I hinted at when we were looking at that chart. You could take your H plus concentration, if you add these exponents together, which is what you would do if you're multiplying exponents, it would always add up to 10 to the negative 14. That is this formula. So this is the formula you use if you are given H plus and you want OH minus, or if you are given OH minus and you want H plus. In order to solve, you're going to need to know a little bit of algebra, just like with the dilution of solutions formula and the molarity formula. So what do? Find the OH minus concentration. You've got the H plus. These are molarities given to you. Just to keep the proper unit. What do we do for A? Where would we put 3.4 times 10 to the negative 5th in this formula? Where you see the H plus, because it says H plus equals this, so that goes where the H plus is, right? So it would be 3.4 times 10 to the negative 5 multiplied by OH minus equals 10 to the negative 14. How do we solve this for OH minus? What do we do now? It's math. I'm looking for OH minus. These two values are being multiplied by each other. So what do you have to do? Divide. Divide both sides by 3.4 times 10 to the negative 5th. Before you start plugging the numbers in your calculator, which you absolutely should, something to remember. If you're dividing by multiple numbers that are being multiplied by each other, you need to put what around the bottom? Parentheses. Don't forget the parentheses or your calculator will give you the wrong answer. So go ahead and enter this in your calculator and see if you get the correct answer. 10 to the negative 14 divided by, remember this line means divided by 3.4 times 10 to the negative 5 with parentheses. See if you get the correct answer. So half the battle is being able to enter this correctly. Find the formula and then be able to use the correct format. This one you have to do a little bit of algebra. If you get it correct, you should get 2.9, two significant figures, right? 2.9 times 10 to the negative 10 molarity. Check to see if that's what you got. It should be to the negative 10, or else something was entered. You didn't do negative 14. check it in your calculator. I'm walking around to assist. You should be checking each of these in your calculator that you're able to get these answers. Because if you're not able to get these answers now, you're not going to be able to get them later. You get it? And if you need any assistance, please raise your hand so I can help. And remember, if you're too shy to ask now, there's tutoring on Monday if you're unsure. Is it -5?
Or just
Yeah, just this side. The other side crosses out. Yeah, that's the algebra to do this. Sorry, Miguel. You cancel that out. That's why you need to do it. All right, let's take a look at the second one real quick. Same idea, same formula. So it's find your formula. Now we're going to plug in 4.2 times 10 to the -10 for H plus. Multiply that times the OH minus concentration. And then that equals 2 10 to the -14 always. Now what?
You do the same thing we did for the other.
Yep, divide both sides by 4.2 times 10 to the -10. And then OH minus is 10 to the -14 divided by 4.2 times 10 to the -10. Make sure you put parentheses around the bottom. Don't miss a sign. And then enter it in your calculator. I get 2.4 times 10 to the -5. Trying to see if you get the same thing. So the next thing we're going to go over is, and we're on the last page now, so the back, we're on the last page, is actually there's a whole nother scale. You've heard of the pH scale, but have you heard of the pOH scale? So there are actually two scales for acids and bases that exist. Yes. That's the same thing. Just in standard form. Not in scientific notation. But that's correct. You're good. All right, so there are actually two scales. One for acids and one for bases. And so to understand what is the pH, the pH is actually a measurement, and you should write this down, of the H plus in the solution. The whole reason we use a pH scale is because, or one of the big reasons we use a pH scale is because people don't communicate to each other in terms of concentrations except potentially in the scientific community. So if you tell a normal person on the news, I have a solution that's 3.7 times 10 to the -8 molarity H plus. Oh my gosh. People don't understand that. Like if you're watching ABC, NBC, CBS News, and they tell you the pH is 6, that communicates more effectively what the pH is, that it's slightly acidic of your water, for example, of your ocean water. And so that's an interesting and important point to bring up. The reason we use pH in the first place is to transform concentrations of H plus into a number that's much easier to communicate with the general population. Yes? Go ahead. It turns out that there's also a pOH scale that exists, and this is for measurement of OH minus. And because the pH scale is a balance between the amount of H plus you have in the solution and the amount of OH minus you have in the solution, the pOH scale is the exact opposite of the pH scale. So when the pH of a solution is 3, the pOH is 11. When the pH of a solution is 6, the pOH is 8. So that leads us to this formula here. The pH and the pOH of a solution will always add up to the number 14. Nice, pretty numbers, no exponents. And also leads us to a couple of other formulas. You heard that the pH is the negative log of the H+. Well, guess what? The pOH, the measurement of OH, would be the negative log of the what? If I'm looking for pOH, I wouldn't be taking the negative log of the acid, I would be taking the negative log of the base. So the pOH formula is the same as the pH formula, but instead of the measurement of concentration of acid, it's the measurement of concentration of base. Which also means, so if I would tell you to memorize, I might tell you to memorize just the P of anything is the negative log of it. And that's the easy way to remember it. Which also means if we know that 10 to the negative pH equals the H plus concentration, then 10 to the negative pOH equals what? What type of concentration? If 10 to the negative pH is the H plus concentration, then 10 to the negative pOH is the OH minus concentration. So it looks like a lot of formulas, but these two are exactly the same. It's just if you're looking at acid or base. And these two are also exactly the same. It's the exact same process for either of them. So you should remember them together. And it's because of this idea that the acid and the base, they have their own two scales that you would be looking at. Now, obviously, if we're comparing and communicating to general population again, we always compare acidity and basicity using pH, not pOH. So if you get a question that asks you how acidic or basic a solution is, you should find the pH. You could figure it out from the pOH, but you have to think backwards, and that's like a lot of work. So it's better to get the pH, and then just remember that pH less than 7 is acidic, pH equal to 7 is neutral, pH more than 7 is basic. Like use one scale to memorize acidity and basicity. So we're going to do a few calculation questions, and then I'm going to teach you what your homework is like today, which is also the final stamp question as well. See a little bit of writing, so I'm going to pause for about 20, 30 seconds, and then we'll move on. Yes. Somebody's out right now when they come back. So before we get to what your homework's going to look like, let's take a look at a couple of additional questions. Calculate each of the following. So now we're working with words again. The H plus ion concentration, that's what we want to calculate, in a juice that has a pH of 4.3. How would we solve the question? All problem solving, where do we start? Notice I started annotating. What's my given and what's my asked for? So my given is pH, and I'm asked for H plus. Once you have your given and your asked for, what's the next thing you should do? Look for the proper formula, right? So what's the formula? You got to use the right formula. If you use the wrong formula, you're not going to get the right answer. Unless you know how to do the corresponding math. So it's going to be 10 to the negative pH equals H plus. You just got to find the correct formula to use, or else your math will become very, very hard and you try this stuff. Now what? We'll get 4.3. Can we leave the answer like this? Is this acceptable?
Yeah. No.
That's a decimal exponent. Can we have a decimal exponent? No. So you're going to have to plug it in your calculator. So you do 10 to the negative 4.3 in your calculator, and you should get 5.0 times 10 to the negative 5 is your H plus concentration. Could I? I'm saying this because I can. Is it feasible that I could ask you, after figuring out the concentration of H plus, what if I told you that I took a solution of it and I diluted it with water, and then I asked you for the new pH. Could you be asked for that?
Yeah.
So that would combine dilution of solutions with pH calculations. And that's one of the reasons I mentioned that although you only have 4 lessons in this unit, it's not going to be that easy because ideas are going to be combined across. It will become less acidic, and then you could be asked exactly how much less and do the calculations with the formula. You see what I'm saying? Where you'd have to figure out with the dilution of solutions formula what's the new concentration, and then do the negative log formula to figure out what's the new pH. So I'm just saying that that's a possibility. Not today, not today's lesson, but in the future. Future use. Not currently. Not today use. Not today use homework. But it could totally be a comparative law. All right. The pOH of a solution that has an OH minus concentration of 5 times 10 to the negative 6. Where do we start? Identify what I'm looking for. Identify what I'm given. So that's molarity, it's concentration. Then find a formula. What's the formula for this? Yep. Whenever I'm looking for the P of anything, it's actually the negative log. And so negative log of the OH minus concentration. This is the formula. And so then just plug in pOH equals negative log of that. 5.0 times 10 to the negative 6. And I'm going to ask you a further question and see if I can get you or if you'll catch the trick. If you get this right, you should get the pOH is 5.3. Now I have a question. Is this solution acidic or basic? How would we answer that? Is this describing to you an acidic or a basic solution? It is not acidic. Yes. It's basic because remember, when you compare, you should be comparing on the pH scale, not the pOH scale, because the pOH scale is inverse. So you could just remember, okay, so pOH is 5.3. Go to pOH of 5.3. That's going to be here. Is that an acid or a base? Basic. So the best way to do that comparison is to find the pH. The easiest way to find the pH is using the formula pH plus pOH equals to 14. So 14 minus 5.3 is, I get 8.7. And then from a pH of 8.7, you can then say, okay, so I know the pH scale above 7 is a base. You might have been able to do it from the pOH scale, but remember, you would have to think backwards. So the best strategy is to find the pH and then figure out if what you have is an acid or a base. Now, the reason I'm bringing this up is because this is going to show up in your homework today. For every solution you have to do the calculations for, you're going to have to figure out, is this an acidic solution, a basic solution, or a neutral solution? So to practice what your homework's going to look like today, so that you get that practice before the lab, so you're all ready to go with the calculations part anyways, this is the last slide that I'm going to go over with you. It says find all the missing values. And this is actually somewhat like what part of your written part of your next test will look like for this part, where you'll be given one of the 4 values we've just learned about and asked for the rest of them. And so you'll have to figure out which formula to use and when, and what strategy to take. So let's take a look at the first line. And so you're going to read this line by line. First line. You've got a solution with a pH of 3. What would be the easiest thing to next find? Because you got to find all of the values. I would find the pOH, always. If I've got the pH or the pOH, I would find the other one. Because I know that the pH plus the pOH always add up to 14. And I can say 3 plus what is 14? What would pOH be? And if your math's bad, like you're not good at knowing what that missing number is, you would just do 14 minus the pH, and that will give you the answer. So 14 minus 3 is what? Nothing. The 2 always add up to 14. 3 plus 11 is 14. All right, I have the pH, I have the POH. What comes next? What should we solve for next? Doesn't it really matter? I would solve for H plus. There's no H2 in this.
Yeah,
We're not working with gases.
so
We're working with acids. All right. Now, if I want the H plus from the pH, can I do that? Can I get that? What's the formula for that? 10 to the negative, so let's write that above. 10 to the negative pH equals the H plus. So 10 to the negative 3 equals the H plus. Do I have to plug that in my calculator, or is that good as is? 10 to the negative 3, that's a whole number exponent. Is that okay to leave it like that? If it's a decimal, you have to calculate it. Not a decimal, you don't have to. You can enter it in your calculator if you want, and you should get 0.001 because that's what 3 is. But you can leave your answer with this. It's fine. Because it's a whole number decimal. What about OH minus? What do we do for this one? What do we find? I know what I would choose. See if any of you feel. I would do 10 to the negative POH equals the OH minus. This is the easiest because you don't really have to solve anything. You just plug in the number and that's the answer. So 10 to the negative 11, because the POH is 11, is your OH minus. And because this is a whole number, you don't have to do anything else. You can leave it as is. And that's the first line. Second one, we're starting with the H plus concentration this time. We can find, if we have one of these four things, we can find everything. Go ahead after Damien. After me. All right, so. Damien, you're next. If I've got the H plus concentration, what would be a logical place to start? You can start more than one place. It's up to you. You will be the problem solver coming up soon. So where should we start? You could. I think finding the pH is the easiest way to go. Because if this is just 10 to the negative 5, I had actually brought up that that means the pH is just 5. But because it's just the exponent, there's no number in front. But you can plug it into the pH equals negative log of H plus formula. If you do that, you would get the pH equals the negative log of 10 to the negative 5, which is 5. You should get the pH is 5. Once you have the pH, what's the next easiest thing to go for? pH. Because the pH and the pOH always add up to become 14. 14 minus 5 equals 9. Because remember, your pH and your pOH always add up to 14. Now I would finally go for the OH minus concentration because that's just 10 to the negative 9. Perfect. Perfect. All right, third line. This time we've got a pH of 7. Or POH of 7. What do we go for first? Sure. And we would just do 14 minus 7 to figure out what the pH is. I would do that as well. I would go directly for that. All right. What next? Doesn't really matter at this point. If you've got the pH, it means you can get the H plus quite simply by doing 10 to the negative pH, which is 10 to the negative 7. And if you've got the POH, you can do 10 to the negative POH, which is also 10 to the negative. And you're done with this one. Neutral, 7, 7, 10 to the negative 7, 10 to the negative. All right, so those first 3 examples were the easiest 3 examples because in none of these examples did we have a decimal. But in the last 2 examples, you do. So let us do when we have a decimal. For this next one, we start with the OH minus concentration. What would be the easiest thing to get first? POH, I agree. So I would do the negative log of, and remember, POH is the negative log of the OH minus concentration. I would do the negative log of 4 4 times 10 to the negative 3 to get my POH. I get 2.4. 4 to one significant figure, that would be 2, because this is only one significant figure. So you can round it to 2. Yeah. My what? Fire extinguishers? Go ahead. There's a couple of them in here. There's
Great.
one there. There's one on the other side. Yeah, there's one on the other side, and then there's one over there.
Great.
3 that I
No.
know of off the top of my head. All right, so I've got the POH. What should we go for next? What should we go for next? I've got the POH. The pH. So how do we do that? 14 minus 2, which is 12. And then we can find our H plus, which is approximately 10 to the negative 12. Last line. pH of 6.4. And what do we go for first? With a pH of 6.4. You could. I would go for POH first, but you could go for either. That works. Yeah, just be careful because I have glassware set up for the lab tomorrow. Thank you. So I'm going to do this one. 14 minus 6.4, which gives us, I get 7.6. Then somebody mentioned to do H plus next, which is perfect. How would we get the H plus? Now, can I leave that like that? No. It's a decimal, so you're going to need to plug that into your calculator. And your calculator should spit out something like 4.0 rounded to 2 significant figures times 10 to the negative 7. Finally, OH minus. How do we get the OH minus? Here. Then there's one over here. 10 to the negative 7.6, which is, in our calculator, you've got to plug it in your calculator to get the standard format, 2.5 times 10 to the negative 8. I'm going to ask an additional question. Because this directs related to the homework or the classwork homework you're about to receive right after you do the question on the next slide. How would we best determine if each of these solutions are acidic, basic, or neutral? What do you think we should look at? So I'm going to ask the question here, acidic, basic, neutral. You've got 4 values for every solution. Which one would be the easiest to look at? The pH. So look at the first one. Is that solution acidic, basic, or neutral?
Acidic.
Second line. Is that solution acidic, basic, or neutral?
Acidic.
Acidic again. Remember, this is how your homework's going to look, so that's why we're practicing. The third line.
Neutral.
pH is exactly 7, which means
Very neutral.
it's the only number that is neutral. Believe it or not, if it was 7.01, it would not be neutral. It would actually be extremely slightly basic. Slightly more OH minus than H plus. Only exactly 7 is what we classify as. Third line, 12. What's that? Basic. And then, fifth line. What's the last one?
Acidic.
Alrighty, so it is 9:12, and you have a question that says your turn. So for the second stamp today, go ahead and solve those questions out, and then raise your hand once you think you have them all, or if you need assistance, and I'll come around and check. I'm also going to go ahead and pass out the homework to make sure you receive it before the end of class. Go ahead and work on the questions and say your turn. It's a grid just like the one I just taught you. So you have to make the decision what you're going to solve for first. And then I'm passing out your homework. When's your homework due? Next week, Monday at the beginning of class to the period 2 bin because it's a paper homework. There you go. All right, I believe Sarah. Nope. It's just enough time. I'm sorry? Oh, Rachel. I thought Rachel went first. No, you're next. It was Rachel, then Damien, then you. Sorry, I said Damien who was after Rachel. Rachel was after that. If you finish before the end of class, raise your hand and have me check it for a stamp. I'm also passing out your homework. Here you go. What happened? And here's your homework. Yes. Want me to check one of them? No, you have to do negative log. Or unless it, yeah, it would be. That's crazy. So yes, it would be 2 significant figures because this is 2 significant figures, so 3.5. 3.5. I'll be right there. Let me hit stop recording real quick.